Let's talk about chaos engineering. So, what does it mean? A one line definition can be that it's a method to test the reliability of a software system by injecting some artificial chaos into it. This method experiments with the functionality and reliability of a system to test how a system would respond in the face of any unexpected disturbance or problem. One can say that it's a practice of deliberately introducing controlled failure or instability into a system to test its resilience and ability to recover, as the goal is to identify and address potential weaknesses in a system before they become catastrophic failures. Chaos engineering is typically used to test distributed systems, such as those used in cloud computing environments. These systems are complex and can be difficult to test fully using traditional methods. So, chaos engineering provides a way to test their resilience under real world conditions. And in that context, a more classic definition for chaos engineering can be: chaos engineering is the discipline of experimenting on a distributed system in order to induce artificial failures to build confidence in the system's capability to withstand turbulent conditions in production. That's fine. But the question comes, why should one perform it? Why do we need to practice it at all? To understand this, we need to see that when IT infrastructure, networks, or applications unexpectedly fail or crash, it can have a significant impact on the business. According to some rough estimates, the damage to business often range from $140,000 to $540,000 per hour, and the impact can be seen not just in revenue loss and operational cost, but in customer dissatisfaction, productivity levels, brand image, and a number of other tangible and intangible metrics as well. So, no matter how you measure it, IT downtime is costly. The combination of cloud computing, microservices architectures, and modern infrastructure improvisations create a lot of moving parts and potential points of failures, making those systems anything but predictable. The moment you launch a new software service, you are at the mercy of the environment it runs in, which is full of unknowns. So, chaos engineering, a decade old DevOps practice, will not rescue your system from those failures, but will definitely help you to build some resilience, tolerance, and confidence into the system, and also help you to develop some proactive contingency plans at a scale to deal with those unknowns whenever they occur. And if performed well, chaos engineering practices also provides the ability to revert systems back to their original states without impacting users. And that saves a lot of time and money that otherwise would be spent responding to system outages. As we all know, chaos engineering as a practice first introduced by Netflix in 2010, and since then it became one of the hot trends for testing in DevOps environment. In the last few years, we saw the launch of a number of chaos testing tools such as Chaos Monkey from the Netflix, Chaos Mesh, Litmus, Gremlin, Chaos Gorilla, and so on. Now the question comes, how do we actually perform it? The how part. So to perform the chaos engineering, to conduct a engineering experiment, engineers first define the steady state of the system they want to test, which is the normal expected behavior of the system. They then define a stress or failure scenario, which is a specific way in which they want to disrupt the system. For example, they might simulate a network outage or a server failure. Next, the engineer execute the experiment injecting the defined failure or stress into the system, and observing how the system responds. They use monitoring tools to measure the system's behavior during the experiment and assess whether it was able to recover from the disruption or failure. So, overall, the goal of chaos engineering is to help organizations build more resilient systems by proactively identifying and addressing potential failure points. Now, the question is how this particular practice is different from the other forms of testing, such as performance or stress testing. And what are the other interesting aspects related to this practice? We'll try to discuss all that in the next part.